السلام عليكم ورحمة الله وبركاته. أهلا بكم أبنائي وبناتي طلاب الصف الثاني الثانوي. إن شاء الله النهاردة بإذن رب العالمين أولا نرحب بكم قبل البدء، نرحب بكم مع تحياتي أنا حسام حسن، منصة البث المباشر وفريقها. نرحب بكم جميعا في حلقة الكيمستري. احنا طبعا النهاردة بإذن الله نتكلم على ال oxidation and reduction, أو how can calculate the oxidation number و converting from the oxidation +1 to +2 or -1 -2. We will explain this changing of the oxidation number in an equation, but firstly I will illustrate you the oxidation number. Before we start now, we discuss this equation, questions. This question shows the correct answer. All the following are characteristics of electrons except. We have many choices. A, they are materials particles. They have wave properties. They lose energy when energy moves from one energy levels to another. They are affected by electric and magnetic fields. We have many choices. These choices are correct. Which is correct here? We have electrons, have number C, they lose energy when they move from one energy levels to another. Electrons absorbs energy to move up and emit energy when they moves down. They don't always lose energy when changing levels. Now, in this properties of electrons, they are materials particles. Yes, it's true, but is not material particle only, but have wave properties. They are affected by electric and magnetic field. This is right. This is correct. But C is incorrect. This is incorrect. Why is it incorrect? Because they lose energy when they move from one energy level to another. This is incorrect answer, but it is the correct in this is choices and this is questions. Now we can to illustrate the difference between valency and oxidation numbers. We have no difference. Just oxidation number is fixed more than valency. If I ask you oxygen valency equals divalent, nitrogen trivalent, phosphorus trivalent, chlorine monovalent, hydrogen monovalent. Okay, but if I ask you why hydrogen is monovalent, why oxygen is divalent, now your answer is, I knew that this information only, mister, but this information I saved it before, but I didn't know why is divalent. Okay. You studied before, for the reaction of oxygen, it's gain 2 electrons when it reacts with another elements. It gains 2 electrons. Okay. So when it gains 2 electrons, that is divalent. That is called is divalent. Why? Because it gain 2 electrons when it reacts with another elements. So the concepts of valence is the number of electrons that an atom of an element lose or gain during the chemical reaction. But the student doesn't know that. But he saves the information about the periods. Oxygen is divalent, nitrogen is trivalent, phosphorus is trivalent, fluorine is monovalent, just. But how can you calculate the valency of any atoms? You must know the atomic number and you must configure that, distribute these electrons in sublevels and determine the number of electrons in the last or the farthest sublevels, so you can determine that. You can determine that. What is the meaning of oxidation number now? Oxidation number, first ionic compounds. Oxidation number of any ions is equals to the valence of this ion, preceded by positive sign in the case of positive ions, okay, and negative sign in the case of negative ions. When any atom, lose one electron, and in this reaction, one electron. Now it is positive one. It's converted into positive one. Now we can to call it a positive one monovalent, like sodium. Sodium atomic number is 11. When electronic configuration of it's equal to neon 10 3s1. The farthest sublevels have one electrons in sublevel s. So it loses one electron when it reacts with another atom. So when it loses this electron, so it is monovalence. When chlorine 17 is 3s2 3b5 electronic configuration of chlorine, 3s2 3b5, okay. When it reacts with another atoms, it's gain one electron from these atoms, so it converts into ion. Negative ion have negative sign. This is negative sign chair, that's or show that this ion is -1, so it is monovalent. Now we can to explain that sign +1 or +2 3 4 5 6 7 7, yeah. Now may the atoms lose into 7 electrons, and convert into +7. So it is the valency here is 7. Now, but we can to call the atom it's gain 7, gain 1 2 3, maybe 4, okay. Not we have no atoms gain 5 electrons. The limit of the limit exceeds for the gaining of electron is 4. Negative sign in the case of negative ions, oxidation number is positive. It indicates that number of electrons the atom has lost to form this cation. Cation, with the meaning of cation, is a positive ion, and we have a 9 is a negative ion. If the oxidation number is a negative, it indicates that number of electrons the atom has gained to form these anions. For example, we have these examples. K +1, it is 19. The atomic number is 19. When electronic configuration, we make electronic configuration of potassium equal to 4s1. Bromine is 3s2 3b5. Sorry, 4s2 3d10 4b5. Now we have Na positive, Cl negative, Mg positive 2, oxygen -2, potassium and Br. This is a bonds. Yes, this is ionic bonds. Now we have +1, -1, +1, -1, +2, -2. This is in the ionic bonds. Now we can understand that by using Ca +2 and CO3 -2. This is atomic groups. This is atomic groups of these compounds, Ca +2, Cl -1 times 2, each one equal to -1. Magnesium sulfate, MgSO4. We have +2 and Mg and -2 in atomic groups SO4. This is anions groups. Okay, now next we have oxidation number of covalent compounds. This is covalent compounds. Anyhow, since there are no positive or negative ions, the charge carries by the atom. We must read this to illustrate it again. Since there are no positive or negative ions, the charge carried by the atom, excuse me, I have atom. If the atom is alone, like oxygen, nitrogen, we have no oxygen atom is a single, but this atom must related or attached with another atom in the compound. Okay, this indicate the electronic displacements in the bond. The bond. This is sure, and this is a bond. Okay, the more electronegativity atom carried a negative. You must study the last lessons, which illustrate the electronegativity, to understand this. Carried a negative charge or a negative sign, and less electronegativity atom carries a positive charge. There are two cases. We have in a molecule with identical atoms such as chlorine, oxygen, ozone, sulfur in vapor state, phosphorus in vapor state. We have the balances here is zero, or oxidation number of this is zero. Electronic displacements in this bonds between the atoms is equal, because the atoms of any molecule of a single atoms have equal electronegativity. Cl, Cl, O, 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 S times 8, P times 4, and so on. We have equal, they are molecules have the same electronegativity in its components, because chlorine, the same electronegativity. Therefore, oxidation number of chlorine is 0, ozone is 0, sulfur in vapor state is 0, phosphorus in vapor state is 0, because is no atom have oxidation number in a molecule like in a pure covalent bonds. And next term we will explain you what is the type of the bonds. Now we can discuss the examples to understand the oxidation numbers and the compounds. When a molecule is composed of two atoms or more with different electronegativities, like NaCl, FeCl2, FeCl3, CuCl2, and so on. So we have many compounds consists of different atoms. Different atoms, so you have different electronegativity. So you have anion and cations, positive and negative. Okay. Now the chair electrons are counted. The chair electrons are counted with the more electronegativity atoms. Note that the oxidation number of oxygen is in most of its compounds is -2, and oxidation number of hydrogen is most of the compounds is +1. This is a number. We have for oxygen equal -2 in measure of its compounds. Hydrogen so is measure of its compounds equal to +1. You must save these two numbers of oxidation number of oxygen and hydrogen. So hydrogen +1 in its compounds only. Oxygen and equal -2 in its compounds. Okay, but you have anomalous states of what? Of oxygen, maybe +2, -half, or positive or -1. Hydrogen and hydride compounds is -1, but it is anomalous states. Anomaly. Okay, this hydrogen, chlorine. Now hydrogen is +1, chlorine is -1. The summation between two ions, positive, negative, equal to 0. +1 and -1 equals 0. Okay, hydrogen, oxygen. Now we have -2, +1, +1. The summation is 0. So have CO2, C plus 4, -2, the summation equal to 0. Equation, we can to understand this and to make exercises for yourself to understand the oxidation number of any atoms. For fundamental rules for calculating oxidation number, we have fundamental rules. You must focus that pure elements, oxygen, nitrogen, chlorine, fluorine, bromine, sodium at sodium molecule, potassium molecule, hydrogen, He2. These pure elements, oxidation number of any pure elements equal to 0. You must save this information. Any elements, in pure state, like oxygen, phosphorus, and phosphorus in atomic state, molecular state, all this vapor state is 0. Monoatomic ion. The oxidation number of a monoatomic ion equal its charge, like Fe plus 2, but we have no single Fe plus 2. Fe plus 2 attached with another anions, like Fe plus 2 with 2Cl negative 1, or oxygen negative 2. Oxidation number of iron here is positive 2. Hydrogen, and most compounds hydrogen as an oxidation number of equal to positive 1, except the metals hydrides. I told that before. Negative 1. This is anomalous. Sodium hydrogen, sodium hydride. Now we have number 4, oxygen. Oxygen usually has an oxidation number negative 2, except in peroxide, H2O2, hydrogen peroxide, sodium peroxide. Okay, oxygen here is negative 1, because hydrogen is positive 1 times 2 equal to positive 2, so oxygen is negative 2 over 2, so oxygen oxidation number equal to negative 1. Now in compounds with fluorine, oxygen with fluorine, OF2, because fluorine is the highest electronegativity in periodic table, so fluorine equal to negative 1 times 2, so oxygen is positive 2. Now this is an expected, where it is positive 2. Sum oxidation number, the sum of the oxidation number in a neutral compounds is 0. Then polyatomic ions, like SO4 negative 2, NO3 is negative 1, the PO4 is negative 3. This is an polyatomic ion. The sum equals the ion charges. Electronegativity in molecules with different atoms, the more electronegative atoms gets the negative oxidation number, while less electronegative atoms gets a positive 1. Okay, now oxidation number of oxygen in peroxide is equal to negative 1, because we have this is positive 1 times 2 is positive 2, so this negative 2 divided 2, so equal to negative 1. Now we have another examples here. Oxidation number of oxygen in superoxides, KO2. K is positive 1, so it's negative 1. Negative 1 divided 2 equal negative half. So oxygen oxidation number here equal to negative half. Oxidation number of atomic groups, you must save these numbers. Sulfate, phosphate, nitrate, carbonate, hydrogen sulfate, chlorate, and silicate. Now these numbers you must save it. You must save these numbers, because to show you how can you calculate and any compounds have these polyatomic ions, these numbers you must save it. Negative 2, negative 3, negative 1, negative 2, negative 1, negative 1, negative 2, and many examples you must know it in atomic or polyionic ions. We have another fundamentals to determine the oxidation number of any atoms in its molecules. We have the number of group oxidation number 1A, 2A, 3A, 4A, 5A, 6A, 7A. This a section of a groups 1A, or usually positive 1, 2A, positive 2, 3A, take a positive 3. From 4A to 7A exchange depends on the other atom it's attached with it in their bonds. 4A negative 4 may be positive 4. 5A may be negative 3 or positive 5. Gain to 3, lose to 5. 6A gain 2 electrons, so its oxidation number equal negative 2, or maybe lose 2, positive 6. Okay, positive 6, maybe negative 2, positive 2, positive 4, positive 6. 7A negative 1 to positive 7. So the oxidation number of 7A may be this, ranges between negative 1 to positive 7. This oxidation number reflects the number of electrons these elements typically lose when forming compound. This is not in atomic structures, but is in compounds. Forming compounds from group 4A to 7A. The oxidation number, these varying oxidation states, allow these elements to form a wide range of compounds with different properties. Now we must know the calculation of oxidation number of many examples. Calculate oxidation number of sulfur in sulfuric acid. Sulfur and sulfuric acid. This is a question for you. Now we must write 2H plus S plus 4O. Why plus? Because the summation oxidation number, to apply the rule I studied before in last slides, now we will apply here. We will apply these rules here. Now H2SO4, 2H plus S plus 4O equal to 0. What's H? The oxidation number of H equal to positive 1. Oxygen is as usually negative 2. Okay, now equal to times positive 1 plus S is unknown plus 4 times negative 2 equal to 0. This is algebraic equation. Now sulfur plus 2 plus sulfur plus negative 8 equal to 0. So sulfur equal to positive 6. Okay, this is a calculation way to understand the calculations of oxidation number of any atom in its compounds. We have another example. Calculate oxidation number of sulfur in thiosulfate anion, or this is thiosulfate ion polyionic groups or polyatomic groups. Okay, you must say that the oxidation number here between 2S plus 3O equal to 0. No. Equal to negative 2. In the last, the summation must be equal 0 because it is a neutral compound. But here is not a compound. This is a section of compounds. This is a polyatomic groups, negative 2. Now we must know sulfur equals to 2S plus 3A equal to negative 2. 2S plus 3O, now 2S as unknown, plus 3 times negative 2 equal to negative 2. Now you can to know this is 2S plus negative 6 equal to negative 2. So sulfur here equal to positive 4. You must divide it positive 4, 2 equal to sulfur is positive 2. Now you understand this slide and the last slides for calculations of oxidation number of any atom in H group or polyatomic groups. We have another example for chromium and chromate anion. The same way, Cr plus 4O equals -2. Cr plus 4 times -2 equal to -2. Cr plus double, this is double quotation, so -8 equals negative, this is a brackets equal -2. Okay, chromium equal to +6. Chromium, it is a transition element equal to +6. Now, we have another example. Calculate oxidation number of iodine in iodate anions. Okay, I plus 4O equal to -1. O oxidation number equal to -2. Now I plus 4 times -2 equal to -1. So iodine equals to, in the last, equal to +7. And these 7 groups, it is halogen groups. Okay, okay. Calculations, we still in the calculations ways. We have many slides to understand accurately how to calculate the oxidation number of any atoms in their compounds. Calculate oxidation number of manganese Mn and potassium permanganate. Now potassium plus Mn plus 4O equal to 0. Calculate oxidation number of manganese and potassium permanganate, KMnO4. K plus Mn plus 4O equal to 0. Now, K plus 1. Why is this plus 1? Because potassium from the 1A, from the components of group 1A, all atoms in group 1A and its compounds equal +1. Potassium, sodium, rubidium, cesium, and francium, they are equal to +1 in Hc compounds. So manganese is unknown. 4 equal to -2 times 4 equal to -8. So the numbers here, +1 plus Mn plus brackets -8 equals 0. So manganese equal to +7. Now, mathematical or mathematic methods to calculate, you must know the equations, must know, apply the summations equal to 0 or what? Or -1, -2, according to the examples I put it in the equations or in the molecules. Calculation of oxidation number of phosphorus in H3PO4. Now, H3PO4, this is another way. This is another way. Another way, H equal +1. This is another way. In the last way, you make equation, and this equation must equal to 0. Now we have another way to save your time. Just now you can choose the way you want. We have +1 times 3, +3. Okay. Okay, this is known. Oxygen 4 times -2 equal -8. Okay, we have two sides, +3 and -8. The summation equal to -5. You must use your calculations, your calculators to know that. Okay, but +3, or you can't use alpha x. Now it is p is unknown. You must use alpha x in your calculators. Write +3 plus x, -8 equal to 0. How now you can to know phosphorus equal to this is plus 3, negative 8 equal to negative 5. This is the summation of oxygen and hydrogen. Now, phosphorus will be, now, think, positive 5. That's right. Positive 5. The summation here equal to 0. Okay, you must know this way again. For NH4, NO3, NH4, we want to know nitrogen and NH4, NO3. We have two polyatomic groups, ammonium and nitrate. Okay, separate between them, NH4 plus 1, NO3 negative 1. So N equal to negative 2 times 3. Here, hydrogen positive 4 times, positive 1 times 4. Okay, we have positive 4 here. Plus, how? To the summation of them equal to positive 1. Now, we must apply this to know. Okay, nitrogen plus 4 times plus 1 equal to plus 1. This summation is plus 1. Okay, so nitrogen equal to here nitrogen plus 3 times negative 2 equal to negative 1. So nitrogen here equal to maybe 4. So nitrogen here is negative 3. Nitrogen here is negative 3. Okay, negative 3. Nitrogen here is positive 5. Okay, so this is right. Now you can, to answer is nitrogen have two oxidation number because it is separate polyatomic groups, ammonium and nitrate. So we have two oxidation number of nitrogen, negative 3 and positive 5. Okay, now we finished the way to calculate or to determine the oxidation number of any atoms in pure elements or in their compounds. Now we want to apply this process and oxidation and reduction process. I can to summarize by redox. Redox means reduction and oxidation process. Redox. Okay, what's the meaning of oxidation process? You studied before oxidation process according to the reaction with oxygen or eliminated oxygen from the compounds. But now we discuss that according to the electron lost or gained. Now oxidation process meaning the process. Oxidation processes meaning the process where an atom or ions of an element loses one or more of electrons, loses electrons, is called oxidation. If the atom or ion lose one or more of electrons, so we can it's oxidized, to make oxidize of it. The process where an atom or ion of an element loses electrons is called oxidation. During oxidation, number of elements increase. This is a key part of reduction and oxidation reactions. You must know is lose or gain. Now how can you know that? Now we have x is positive 2. Now it's converted into x positive 5. Now the oxidation number converted from positive 2 and positive 5 is the last products. Now you can to know the oxidation number increase. We have another way. You must subtract. Okay, focus in this words. Focus that you can to subtract positive 5 from positive 2. This is exchanging. Okay, if the results equal to positive, now you can to call it oxidized. If the results equal to negative sign, okay, you can to call it reduced. Now we have positive 5 minus positive 2 equal to positive 3. Okay, it is lose through electron. It's lose 3 electrons. So it is the, as now we have explained this. You need to subtracts the oxidation number, the product X positive 5 from the oxidation number of the reactants X positive 3. So the difference will show that change in oxidation states, indicating whether oxidation or reductions has occurred. Now you must subtract to know the number of electron lose or gains. Okay, if your products indicated that atoms or ions has lost 3 electrons, it means that oxidation number has increased by 3 electrons. 3 electrons. Why 3 electrons? Because the results of this subtractions equal to results positive 3, positive 5 minus positive 2 equal to positive 3. Now you know the results. Good to know the oxidation or reduction process is takes place. Okay, its number has increased by the 3 units. Each unit is equal to 1 electron. If aluminum Al loses 3 electrons, the reactions can be represented as aluminum converted into Al plus 3 electrons. Now, we must know reduction process concepts. The reduction is vice versa of these. Reduction process, the process where an atom or ion of an element gain electrons. Gain electron is called reduction process. During reduction, the oxidation number of elements decreases. Okay, this is a key parts of redox. Key parts of redox. For example, reaction. This reaction, reduction and oxidation process. Reduction and oxidation process. So it is redox, reduction and oxidation. For example, the reaction Cl2 plus 2 electrons, it converts into 2Cl negative. It is gain 2 electrons. So chlorine is reduced by using 2 electrons. Okay, chlorine gains 2 electrons to form 2 chloride ions Cl negative, and this process is reduction process. We have another example, X positive 6 to positive 3. X positive 6 to positive 3. Okay, subtract the positive 3 minus positive 6. So the results equal to negative 3. It gained 3 electrons. And reduction processes occur in this. Okay, we must know the explains this. You need to subtract the oxidation number of the products X positive 3 from the oxidation number of the reactants positive 6. This is difference will show the change in oxidation states, indicating whether oxidation or reduction has occurred. Now we have reduction occurred in these equations. Okay, if the products indicate that the atom or ion has gained 3 electrons, it means the oxidation number has decreased. Again this. If the products indicate the atom or ions has gained 3 electrons, it means the oxidation number has decreased by number of electrons will gain 3, 4, 5, 6, or another. I'm sorry, 1, 2, 3, 4. This is the limit. Exceed by 3 units. For example, if nitrogen ions and plus 3 electrons, it's convert and negative 3. Now N equal negative 3 and reduce the N to N negative 3. The reaction can be represented in this way. Here is the oxidation number of nitrogen change from 0 to negative 3. Oxidation number is increased? No, it's decreased because it's gained 3 electrons. From 0 to negative 3, indicating that it's gained 3 electrons in this reaction. We have this example, this equation, K2Cr2O7 plus 6Cl FeCl2 plus 14 HCl. Production is 2KCl plus 2CrCl3 plus 6 FeCl3 plus 7 H2O. Now we can to convert this equation into redox equation. How to make that? You must calculate each atom here and this components of this equation. And when you calculate the oxidation number of each one, now you can't know the exchanging of the oxidation or reduction process. Now, potassium K2Cr2O7 6Fe, this is separation of each atoms in reactants K2Cr2O7 6Fe Cl2 plus 14H 14 and Cl. Okay, this is the reactants. Now we have the products 2K and 2Cl plus 2Cr plus Cr3 plus 6Fe plus 3F plus 7H. The number before, this is a balance only. This is a balance. But to calculate the oxidation number doesn't matter for this number before. Okay? Okay. Now we have 1 plus 1. Potassium is plus 1 times 2. So potassium have positive 2. But the oxidation number of potassium equal to positive 1. But the oxidation number of potassium equal to positive 1. I mean each atom equal to positive 1. Positive 2 here for 2K. Okay. Cr2. Okay. As none is unknown. Okay. Okay, oxygen equal to negative 2 times 7 equal to negative 14. So chromium equal to positive 12. Positive 12 of what? For 2 Cr. Each Cr equal to positive 6. Okay. Now 6 Cl equal to negative 1 times 2 negative 2. So Fe is positive 2. Now hydrogen is positive 1, is negative 1. Chlorine is negative 1. Now we have potassium positive 1, chlorine negative 1, and chlorine Cl3 is negative 3, so Cr is positive 3. Fe will calculate it by using Cl equal negative 3, so Fe equal to positive 3. Hydrogen here equal to positive 1 times 2 equal to positive 2. Okay, now we calculate all the atoms and the reactants and the products. Okay, these atoms will convert it into another ions from the exchanging here. But we have another atoms doesn't exchanging. Okay, now we interested in the exchanging only. But each atom or ion doesn't exchange. Okay, this is doesn't exchange. No, it is no oxidation or reduction occur in this or take place for this or this atoms. Okay, now we discuss chromium plus 6 converted into chromium plus 3. Now we have okay, chromium divided positive 12 divided 2. Positive 12 over 2 equal to positive 6. Okay, we'll convert into chromium positive 3. Okay, we discuss this exchanging here. Now positive 6 positive 3, subtract positive 3 from positive 6 equal to negative 3, so it is gain 3 electrons. So it is the reduction process here because we decide that from this equation, or we conclude this from this subtractions process. Okay, when subtracts chromium plus 3 from chromium plus 6, this is the number equal to negative 3. So is oxidizing agent. Why is oxidizing? Because it is reduction process occur in this Cr plus 6. Any ions or atoms will reduce, we can to call it oxidizing agent. Oxidizing agent. Now, so K2CR2O7 oxidizing agent. Now, we transfer another Fe plus 2, Fe plus 3. You must subtract plus 3 from plus 2 equal to plus 1. This is oxidation process. When you when subtracts Fe plus 3 from Fe plus 2, it is lose 1 electrons. Now, Fe plus 3 plus 2 is reducing agent. Why? Because it reducing agent because it oxidized in this reaction. Okay, so FeCl2 is reducing agent. Now we discussed the exchanging of reducing and oxidation process from this equation. So we have redox equations: Cr plus 6 plus 3 electrons. The result is 3 Cr plus 3. Now 3 why you multiply this 3? Because you must balance of electrons between two sides. Cr gains 3 electrons. Iron lose 1 electron. We must balance between these electrons. This electron equal 3. So they multiply Fe into 3. 3 Fe plus 2 converted into Fe plus 3. So this electron will lose from each or some, sorry, for all Fe, 3 Fe. Now, the redox equation Cr plus 6 plus 3 Fe plus 2, it results into, the result is Cr plus 3, the plus, and Fe plus 3. This is called redox equation. Now, we define the redox equation and reducing agent and oxidizing agent from this is examples and illustrate that. Now we finished our curriculum now, and I will hope nice meeting, and I will hope nice turn for you, and we will meet for revision in the next time, inshallah. The meeting is over now, and we will see you later, God willing, with my greeting, Mr. Hussam Hassan, in our groups of Ministry of Education in Egypt. Thank you, my students, and thank you for good hearing and good listening. Thank you, and bye-bye. Assalamu alaikum wa rahmatullahi wa barakatuh.